Okay, so let's go on to the first compound of group 15, that is known as nitrogen. इसमें हमने 4-5 compounds discuss करने हैं. One is nitrogen, the other one that is going to be ammonia. Then we have to discuss the oxides of nitrogen and finally the oxacids. ठीक है, nitric acid we have to discuss. Now उसके अलावा group 15 के phosphorus के also we need to discuss 2 or 3. One which is phosphine, PH3 we will discuss. Then the halides which we just discussed, PCl3 and PCl5, वो हमने detail में पढ़ना है. And finally then we have to discuss the oxacids of phosphorus, their structure and their basicity. Okay, so let's go on to the first compound over here, nitrogen. Nitrogen जो था, that was first isolated by the scientist Shaillee, and he named it as foul air, right? Foul air, why? Because this was not supporting life, therefore it was known as foul air, right? फिर उसके बाद later on another scientist Rutherford, Rutherford ने इसको क्या बुलाया? He called this air as mephitic air. Mephitic air. Mephitic air means which is a killer of life. मतलब कि अगर सिर्फ there is going to be nitrogen which is present and there is no oxygen present, what nitrogen does is it just makes a blanket around anything, as a result of which if oxygen is trying to go inside that particular blanket, oxygen fails to go inside the blanket and therefore it is known as mephitic air or air that kills. ठीक है? Now when we talking of nitrogen, let's go on to the occurrence of nitrogen. Nitrogen, it occurs in the atmosphere, free in the atmosphere. Approximately 75% of nitrogen by mass occurs in the atmosphere, and by volume it is even more, 78% of the atmosphere that consists of nitrogen, right? Apart from that, it is also formed in the combined state. जैसे for example, it is found in nitrates, ठीक है? Sodium nitrate in the combined form. This is known as child salt peter, and it is also present in the form of KNO3, which is known as potassium. Which is known as Indian salt peter. Which is known as Indian salt peter. ठीक है? Now, apart from this, when we talking in the atmosphere, it is a constitute. It is an important constitute of all living things. As it is present in proteins, it is going to be present in nucleic acids, RNA and DNA, ठीक है? It is also present in urea, and then it is also present in all the amino acids, right? When we are preparing the nitrogen, preparation of nitrogen can be done by the following methods. We can heat nitrites of the type NH4NO2. Then this is going to be heated. This is going to give us N2N water. Okay? उसी तरह से if we are heating potassium dichromate, if we are heating potassium dichromate, this is going to give us right? So this is how we can prepare nitrogen. pure nitrogen that is prepared by reacting ammonia with copper oxide. When it is going to give us nitrogen and copper and water. Now इसको आप balance कर लो reaction को. We will have 3 and 3 and 3. This is how we can balance the reaction, right? Other methods, we can also prepare nitrogen from urea by reacting urea with nitrous acid. Okay, this nitrous acid, it is prepared by reacting sodium nitrite and HCl. HNO2. ठीक है? So जब हम लोग यूरिया की रिएक्शन करते हैं इसके साथ, it is going to give us CO2 plus water. Okay, so balance करो इसको. We can have 2 over here and 2 over here, and how many water? 4 2s are 8. 8 to 9 here again. We can have 2 over here. 5H2. ठीक है? So this is how we can prepare nitrogen. Pure nitrogen may also be got from metal azides. That is, if we have barium azide, the formula of barium azide, that is going to be BaN3 whole twice. This is known as barium azide. This, when heated, it can give us very pure form of nitrogen. So these are the methods of preparation of nitrogen. Let's go on to the properties. Properties of nitrogen. First of all, nitrogen that is going to be, we cannot see nitrogen in the atmosphere, so it is colorless. There is no taste, tasteless, and it is going to be odorless. ठीक है? It is a colorless, tasteless, odorless gas, and it is sparingly soluble in water. It is also sparingly soluble in water. Okay? Now this gas nitrogen, it is non-poisonous. It is non-poisonous, but at the same time, it is a non-supporter of life. Why it is a non-supporter of life? But because it cuts down the supply of oxygen. Therefore, it is going to be a non-supporter of life. So that is the reason why it was known as the killer gas. ठीक है? फिर उसके बाद number 3, it does not help combustion. It is a non-supporter of combustion. It is going to be non-supporter of combustion, and also it is non-combustible itself. It is going to be non-combustible itself. Right? The next, very, very important, which we have been discussing, that it is chemically inert. It is going to be chemically inert, which means that it does not have chemical reactivity under ordinary conditions. But जब हम लोग temperature increase करते हैं, then at that time nitrogen can still react. Otherwise, it is chemically inert due to a very high bond dissociation energy of 942 kilojoules per mole, and also due to the presence of triple bond. ठीक है? फिर at higher temperatures, as I just told you, there are certain reactions of nitrogen which can be looked at. Okay, so at higher temperatures, there are following reactions of nitrogen. Which can take place. The first is the reaction of nitrogen plus oxygen at a very high temperature of 3000 degrees centigrade. When nitrogen that is converted to nitric oxide. Okay, so you can see over here the temperature जो है that is very high. Then second reaction is reaction of nitrogen with hydrogen at a temperature of approximately 700 Kelvin and at a pressure of 200 atmospheres. The reaction takes place in presence of a catalyst which is Fe, iron, and in presence of a promoter which is molybdenum to give us a suffocating or a gas with a pungent smell, ammonical smell, which is known as ammonia. ठीक है? फिर उसके बाद it can also react with certain metals to give respective nitrides. Like for example, if we are reacting lithium with nitrogen, temperature the reaction takes place at 450 degrees centigrade. It is going to give us lithium nitride. Similarly, if we are reacting it with magnesium at the same temperature 450 degrees centigrade, it is going to give us Mg3L, magnesium nitride. ठीक है? एल्यूमिनियम के साथ भी इसी तरह से रिएक्शन होती है, but the reaction takes place at a very high temperature of 800 degrees Celsius and we get aluminium nitride. So these are the reactions with metals giving their respective nitrides. Okay? फिर उसके बाद non-metals like boron and silicon also react. So the fourth reaction which we are going to do, that is the reaction with non-metals like boron. बोरोन के साथ ये रिएक्ट करता है to give us boron nitride, right? Similarly, सिलिकॉन के साथ रिएक्ट करेगा nitrogen to give us silicon nitride with the formula Si3N4. Okay, now then in all these things you can see it is reacting with elemental state elements over here, oxygen, nitrogen, over here with metals, and then over here with non-metals. It can also react with compounds like alumina. Alumina is Al2O3, ठीक है? इसके साथ ये रिएक्ट करता है plus nitrogen at a temperature of 1273 Kelvin to give us aluminium nitride and with that it is going to give us carbon monoxide. This method which we are using over here, the last method, this is a method which is used to purify alumina. So इसमें से इसकी जो volatile impurities है, they can be removed by using charcoal and nitrogen. मतलब in presence of carbon we are reacting it with nitrogen, then we are going to get pure alumina. ठीक है? So these are the reactions of nitrogen. Then we come to the uses of nitrogen. Let's go on to the uses of nitrogen. First and most important use of nitrogen is to provide an inert atmosphere for certain reactions. And one of the most most common uses of nitrogen with respect to this inert atmosphere is the flushing of nitrogen in packets of chips. So you must have seen in the market जो chips के packet होते हैं वो काफी fluffy होते हैं, फूले हुए होते हैं. That is because inside that nitrogen that is flushed, so that oxidation or hydrogenation of oils that does not take place. Otherwise अगर chips पुराने हो जाते हैं और hydrogenation oils की हो जाती है, the oils which are present they turn rancid and they start giving a bad smell. ठीक है? So nitrogen जो एक inert atmosphere provide करके रखता है inside those packets of chips, it does not allow any reaction to take place. ठीक है? So this is one important use. Now this inert atmosphere, again and again I am telling that the inert atmosphere is due to non-reactivity of nitrogen. Why? Because nitrogen has a high bond dissociation energy of the order of 942 kilojoules and hence the bond between them it cannot be easily broken. ठीक है? Second जो है, it is used as a blanketing gas. Blanketing gas. Now, what do we understand by a blanketing gas? It is whenever we want to protect any substance by action of oxygen on that substance. So we just cover that particular substance with nitrogen gas. So that is why it is used as a blanketing gas. Especially this kind of a thing is done for storage, the same as I have just told you when we are flushing nitrogen inside the chips. So we are blanketing those all chips with the help of nitrogen so that oxygen is unable to react. So that is known as blanketing. Okay, protecting any kind of storage from reactivity of gases like hydrogen and oxygen on them. Okay. Then the third is it is used to fill electric bulbs. It is used to fill electric bulbs. It is also used in the manufacture of many important compounds like ammonia, nitric acid and calcium cyanamide. This calcium cyanamide, this is used as a fertilizer under the name of nitrolim. Okay? It is used as a fertilizer under the commercial name of nitrolim. Right? फिर उसके बाद it is also used, liquid nitrogen, it is used as a refrigerant. Liquid nitrogen that will be used as a refrigerant, and also liquid nitrogen that is used for cryosurgery in gynecological problems. Cryosurgery is generally used to decrease the temperature of the body part to such an extent that even if scrapping of certain portions of that particular skin that is taken out, it is not felt. Okay? Because the temperature बिल्कुल आप भी खुद भी देखते हो कि अगर आपने बर्फ के अंदर अपना हाथ रखा हुआ है, उसके बाद what do you say? You say that your hand has gone numb. सो जाता है या सुन्न हो जाता है. ठीक है? Why? Because temperature is decreased to such an extent that there is no feeling to the skin. Similarly is happening over here in case of cryosurgery. The temperature of any part of the body from which the pathological infection you can say has to be removed, in that case we decrease the temperature of that body part to such an extent that nothing can be felt. Okay? So that is also done with the help of liquid nitrogen. So this was the first compound, which is nitrogen. There is another term which is known as active nitrogen. Now what do we understand by active nitrogen? Whenever we are flowing an electric discharge through nitrogen under very low pressure, right? Under very low pressure, in that case what happens is we can see a fluorescence which appears, or a luminescent which appears over there, okay, as a result of which the reactivity of nitrogen that increases to a certain extent. So that particular nitrogen whose reactivity increases by allowing an electric discharge to pass through it at low pressure, that gives rise to nitrogen which is known as active nitrogen. Although this is temporary, थोड़ी देर के लिए वो active रहता है, then again it comes back to its original position. ठीक है? Then we go on to the second compound, which is ammonia. In fact, this is the first compound of nitrogen, ammonia. Ammonia, NH3. Now, ammonia is found in traces in the atmosphere. It is found in traces in the atmosphere. Now, this is basically formed by the bacterial decomposition of organic compounds or organic matter. Bacterial decomposition of organic matter. Like if we're taking urea, and if on this water is going to react, it is going to give us ammonium carbonate. Okay, this ammonium carbonate then decomposes to give us a gas which has a very peculiar smell. This decomposes to give us ammonia plus carbon dioxide plus water. Okay, so ये जो यहाँ पे अमोनिया बन रहा है, you must have seen कि जब आप you going towards the plains in the farms, when you're crossing the farms, you can see that there is a typical kind of smell which you can feel or which you can smell. That smell is due to decomposition of urea, which is used as manure in all the farms. Okay, so what are they doing? They are watering all those plants over there or all the crop over there, as a result of which ammonia that is going to be liberated. Okay, so it is formed by this. Then we say that on certain planets like Jupiter, and Saturn, ammonia is present in abundance. Okay, now ammonia was first isolated by Priestley. Priestley was the scientist who isolated, and during that time it was first of all known as alkaline air, because it was alkaline in nature. ठीक है, clear हो गया? When we are going to the preparation, I have already discussed the first method of preparation over here, that is decomposition of urea. Let's go on to the laboratory preparation of urea. In case of laboratory preparation, it can be prepared by any kind of ammonium salts, like if we are reacting ammonium chloride and we are doing the reaction with NaOH. So by reacting NH4 and NaOH, we can get ammonia. We can also get ammonia by reacting ammonium sulfate with sodium hydroxide. Now in this case again we are going to get ammonia. And plus water. So these are the laboratory preparations. Now when we are doing the manufacture of ammonia in large scale, the manufacture of ammonia is done by a process which is known as Haber's process, in which we are combining nitrogen with hydrogen to give us ammonia. Okay. Now in this case it is seen that energy is given out, so the reaction that is going to be exothermic, and delta H in this case, that is minus 46.1 kilojoules per mole. Okay, minus 46.1 kilojoules per mole. Now we can see over here that the reaction is exothermic, number one, and second, the reaction that is reversible in nature. So in this case, to get the best yield of ammonia, we are going to follow the Lee-Chatelier principle. According to Lee-Chatelier principle, the conditions which are required to produce maximum amount of ammonia, number one, because of exothermic nature of the reaction, the temperature should be low. We will get best yield of ammonia if the temperature is low, and the temperature is kept to approximately 700 Kelvin. Okay. Now over here you can see that on the reactant side there are 4 moles which are present, and on the product side there are 2 moles which are present. For the forward reaction to take place according to Lee-Chatelier principle, the pressure has to be low, because if the pressure is low, the reaction goes towards lesser number of moles. Okay? So यहाँ पे sorry, not low, high. So यहाँ पे the second condition which we are going to follow, that the pressure should be high. Okay? So the pressure which is kept over here, that is approximately 200 atmospheres. And finally, the reaction takes place in presence of a catalyst which is iron. Okay? And this iron is promoted by promoters like molybdenum, K2O, or aluminum. So these are the 3 conditions which is going to give us the best yield of ammonia according to Haber's process. Clear ho gaya? So this is how we are going to prepare ammonia. Let's go on to the properties of ammonia. Properties of ammonia. The first property of ammonia is that it is a colorless gas with a pungent smell known as the ammonical smell. With a pungent smell known as the ammonical smell. Okay? Number 2, it is lighter than air. It is going to be lighter than air. And number 3, it is highly soluble in water. Highly soluble in water to give us an aqueous solution of ammonium hydroxide, NH4OH. Because of the lone pair of electrons which are present, we say that ammonia is basic in nature. So, if we are dissolving ammonia in water, it is going to give us hydroxyl ions. Due to the presence of these hydroxyl ions, it is seen that ammonia turns red litmus blue. Okay, it is going to turn red litmus blue because of its basic nature. Now, because of its basic nature, ammonia has a tendency to react with acids. So अगर हम NH3 को HCl के साथ react कर देते हैं, it is going to give us a salt, which is ammonium chloride. ठीक है? So because of its basic nature, it has a tendency to react with acids, and also it can react with sulfuric acid in a similar manner. Okay, it is going to give us ammonium sulfate. It is going to give us ammonium sulfate. Then when we talking of the reactions of ammonia, it behaves as a weak base. Because of this nature, that is, because of the weak base, it has a tendency to precipitate many salts. ठीक है? जैसे for example, if it is reacting with zinc sulfate and we are taking the aqueous solution of ammonia, this is the aqueous, sorry. We are taking the aqueous solution of ammonia over here, NH4OH. So we get a white precipitate of zinc hydroxide. We are going to get a white precipitate, and we get ammonium sulfate. Okay. Similarly, if we are reacting it with FeCl3, that is ferric chloride, we are going to get a brown precipitate of Fe2O3. So इसके साथ जब हम reaction करते हैं, dot XH2O, this is a brown precipitate, plus we will get ammonium chloride. Clear? Now we already know that ammonia has a lone pair of electrons. Due to the lone pair of electrons on ammonia, it behaves as a good complexing agent. It can react with all those metals which have empty d orbitals, and these d orbitals, what they are going to do, they are going to accept the lone pair of electrons which are present in ammonia, and therefore forms coordinate complexes. ठीक है? So जैसे for example we have Cu2 positive that is going to have vacant d orbitals, और इसके साथ अगर हम अमोनिया को रिएक्ट करते हैं, you can see that there are lone pair of electrons which are present in ammonia. Those lone pair of electrons can easily accommodate or easily take the vacant d orbitals which is present in copper, such as to give us a coordinate ion of the type CuNH3 2 positive. ठीक है? So wherever empty d orbitals are going to be present, in that case ammonia can easily complex with that reagent or with that metal, and especially these kind of reactions are very common in D block. So when we will do coordinate chemistry, we are going to take ammonia as an electron donor, which is going to be known as a ligand. ठीक है? So that we will do when we are going to do the coordinate chemistry. Then what are the uses of ammonia? That is the last topic which we are going to discuss today. Uses of ammonia. when we doing the uses of ammonia, the first use of ammonia is that it helps us to produce nitrogenous फर्टिलाइजर्स। ठीक है, कौन कौन से हुए वो, जैसे कि अमोनियम नाइट्रेट, यूरिया, अमोनियम फॉस्फेट, एटसेट्रा। ठीक है, फिर उसके बाद सेकेंड इसकी यूज क्या है, इट इज यूज्ड इन द मैन्युफैक्चर ऑफ nitric acid. It is used in the manufacture of nitric acid and liquid ammonia is used as a refrigerant. Is used as a refrigerant. Right? So today we are only going to do till here. Okay?